I'll quickly, start with my little background. I think summary of what I do currently, but let me really tell you like my journey, because that's where I want to connect to this, process of DevOps. What is there and why there is a demand, and what really it needs to make you industry ready, I would say, right? And maybe if some of you are already working, you will relate very well with what I'm talking. Okay, so yeah. So before I really jump onto the topic, let me first tell you that for last 16 years in the IT industry, when I started my career in 2005 as a software developer, guys. Okay, so then I used to work on C++, okay, and Linux platform. And I have seen quite many things. And since it was my very first job, I was super excited with many, learning ambitions. I learned so many things, and I thought I will really, go long. And that's what I believe. I'm confident I have achieved what I wanted to, right? But then how the industry evolved, okay? When I started in 2005, then today 2022, okay, today 2022, for 16 plus years, okay, from software developer to a DevOps professional, DevOps and SRE functions. I have led multiple teams in last 4 years, I would say 3.5 to 4 years, right? And before that, I used to be in multiple areas, okay? Especially the DevOps has become more mature, and it has taken up really much stake in the industry in last 4 to 5 years, I would say, okay? So the journey was like, software developer to there was a need when I was working with Tata Communications, right? So we wanted to develop our software in house. Okay, Tata used to have the third party software, and we wanted to develop in house and replace that. Okay, and that's where we started designing based on C++. And we wanted to have this in a modern way, right? So we came up with Docker. We understood how we can create microservices, how we can develop in a more agile way, right? And market it, right? So that's how, in the journey, we understand what is the best, which will be there for 10 years, 15 years, 20 years. Okay, so if I talk about the evolution, right, in the industry, right, to start with, in 2005, when I joined, I got one hardware, I would say a server, okay, meaning there were 7 developers. I was working on a soft switch, okay, a telecom domain, based on 3G that time. Maybe, that was early time for 3G. So, the hardware, Sun Solaris, okay, operating system. Sun Solaris is a Unix operating system, guys, okay. Unix operating system. So this was really very, very successful operating system. It was a de facto standard for all the carrier grade solutions, or I would say the production needs. But this used to come along with their hardware. Okay. And I remember every developer used to have this hardware machine for their development activities. Okay. So that's what I have started with, right? And if I look at the entire process, what has changed, evolution in the digital era, okay, my handwriting is not really so good, but I hope I will make it at least understandable. So development process, okay, so dev process, okay, and then application infrastructure. So I'll take 5 minutes, but I will jump onto various tools on DevOps. Okay, but I think this background and history will definitely help you, right? Anybody heard about waterfall dev process? Okay, SDLC, software development lifecycle. Then maybe a lot of people already know about Agile. Okay, and then somebody also talk about DevOps, but people talk DevOps and Agile together, right? So we will talk about this. I will give you a clarity, right? Even I don't have too much time here, but still in this 1 hour, I'll make maximum of it.
దాని గురించి just roadmap ante.
All right. So, an application infrastructure, right? Monolithic. Now, if you don't know much, maybe I'll try to give you a little idea about it. Then entire applications and microservices based architectures, right? So maybe if you are working on Java and Spring Boot, if you heard about, maybe you're working there, if you know about Docker, Kubernetes, if you know about any application which you want to run as a microservice, so you can probably relate. Okay, so that's the evolution. Very first, like in 2005, when I was working on that C++ based application, we used to build that, and it used to take 6 hours to build that entire software. Okay, so and later on they realized that we can separate out some of the things, right? Maybe the front end, maybe the business logic, maybe the database. So they separated out, right? They wanted to create those components loosely coupled, right? So that if one component is down, so it should not impact on others, right? Instead of keeping everything together like in monolithic, right? So application infrastructure, right? Maybe if you recall, or if you heard about, earlier we used to have data centers, right? Hosted applications, the infrastructure management application where we deploy. So I was talking about cloud like Azure, AWS, GCP, private cloud, or IBM cloud. So that's where our deployment goes, right? And the deployment process, I would say, our deployment or packaging, right? How do we package our softwares, bundle it and deploy, right? That package goes with unlike physical, unlike virtualized. Okay, these days we talk about containerized. Okay, and something called container. Now I want to come containerized. Okay, I want to talk to you about a couple of important things, right? So if you look at this journey, right, from top to bottom, maybe in 20 to 25 years, I would say, right? So things have really changed a lot. Okay, virtualization is still there, right? It's a very successful technology, right? But containerization helps you create your microservices based applications and manage it really well, right? So, and especially if I talk about workload, okay, 20 years ago, let's say Amazon traffic or Flipkart, or maybe even if I go 15 years, not 20 also, right? So we used to give, let's say a lot of people used to put orders, right? And if I think about today, right? So obviously, now kids also place orders, right? My daughter, many a times she order what she need, right? So that's what, like, the traffic, the workload has drastically increased, right? And it's not easy, guys. Can't imagine if monolithic can really take this kind of a load today, right? Forget about the other challenges, right? Managing, maintaining. So the evolution happened in all these areas, right? And that's where, so microservices, cloud, containerization, virtualization, DevOps, right? And that is the need in the market. Okay, that is the first thing somebody asks, be it's a development role, be it's a DevOps, a specific role in DevOps, or if you are working, or if you are growing in your career ladder. So wherever you go, you need this kind of a knowledge, right? So this is a background. Okay, I think I will move on quickly on jumping onto the topic, because I want to make you understand what is there in DevOps and how this will help you, shape your career in a better way. Okay, I assume you guys are having 0 to 3 years of experience. So if that is the case, I think this approach or this guidance will definitely help you, right? And feel free to ask questions. Feel free to connect to our counselor. They will help you, right? And maybe they will guide you best, right? So, now I will first tell you what is that DevOps we have been talking, right? So what is DevOps, and what are other things like cloud also I'm saying, right? I'm saying containerization, I'm saying creating microservices. So who creates that? So probably not everything a DevOps engineer has to do, right? But there are few things, which you will understand in the discussion when I talk about a process, right? A DevOps approach, I would say, right? So before I jump there, So let me quickly take you through a little bit of theory behind this. What is the DevOps and what it really means? A little bit to connect your understanding, those who are completely new, and those who know some basics of this, they will relate more in my next discussion. After a couple of minutes, I'll be talking about the approach. Okay, so DevOps, it's a process, it's a approach. It's not a technology, not a software, guys. Okay, DevOps is not a technology. DevOps is not a software that you're learning and you're going like Java, right? It's not the one. So it is the approach which helps you reduce the gap between the developers and operations teams. Now, for a business, right? For any business, for example, any business person or any software company, they want to develop an idea, right? So there will be few people, experts, right? They will be working on that. They are probably hired with the investment they have, or they are probably the techie people who want to start something, right? So these people work on an idea. Agree? So they work on idea, they work on designing that. Okay, they work on planning it, right? And it is all the software product I'm talking, or software idea I'm talking. Probably they want to implement it, right? Implementation means implement, right? Implement. So if I talk implementation, I would say coding, right? Maybe they want to code from scratch. Maybe they want to get some code from the open source and make some changes, and it will be they can give some shape to that, right? So that's the idea, right? That's the R&D, that's a team. Okay, or many times we call this as a dev team. But only dev team developing something cannot be commercialized. Okay, or only these people cannot, right? It could be, but the kind of scale we are thinking, or projects, right? If they are large scale projects, it's not possible for one person to do everything, right? So that's where the operations comes in picture, right? So they need to know, they need to have someone to give feedback to them. Okay, suppose these people wants to create a car, right? So yes, I mean, that's a good idea, right? They can probably work on that, right? And they create something like this, right? But they want to know if it really solves the problem which they intend to, right? So operations people will do checks on the, sorry, do checks and provide feedback to the developers. Provides feedback. Okay, they say they actually, you assemble everything, but unless you run this, you make this car to go from A point to B, right? It won't really create any value. Correct? So yes, somebody will try out, somebody will say, somebody will ask customers, the end customer, right? And they collect that feedback and they give it to the dev team. Okay, so there is always a very, very good bonding here, right? There is always a bonding, right? There is always sometimes a fight, sometimes the thoughts, discussions, everything comes here. There is some kind of a relation between dev and operations, right? And operations means there is a QA also somewhere, right? Quality assurance, testing, validations, and then that is what I said, checking, then making sure this runs, right? The operations teams also do some kind of a monitoring, etc., right? So you will connect more when I talk a little bit more about the process. Okay, give me some time. But for now, developers and operations, I hope in a simple words I try to convey what developers do and what happens at the end. What is the end objective? I want to make this available to the customers, right? So till then, there are two major parts of that organization, or whoever is running that business, right? So they need to know who is their development team and who is that operations, who will validate, who will check, who will certify that what is being created and as per the requirement in the market, or as per the customer demand, right? It could be anything, guys. Even if you talk about Zomato, okay, you can talk about your Flipkart or any kind of application, right? So you're creating something, there has to be a team to validate, to check continuously, to monitor how things are happening. Agree? So that's what this slide talks about. Okay, there's a developer and there is a QA and there is a operations. This is a bonding. This is the, the common part in all these different teams, something we can achieve through DevOps. DevOps can be a dedicated team who will serve that purpose. Okay, so I will quickly take you through some more discussion, a bit of a theory. So it's a combination of development and operations, as I mentioned, right? And probably 1 second, yeah, this slide will tell you it's a continuous process. Okay, it's a continuous process. This infinity symbol, right? You will, you put DevOps in Google, you will find everywhere this infinity symbol, right? So I want to relate with this. Okay, why this infinity symbol? What is the code? What is plan? What is monitor, etc., etc.? There are quite many things here, right? So sorry, code, build, test, release, deploy, and this is a whole thing continuously happening. Okay, and why this happens, right? So as I mentioned here, so the R&D team will do design, plan, okay, and they do code. Okay, I write code to make it simple for you. Coding means they do implement that idea, okay, to productize or to make it commercialized, right? Or to make it usable thing, right? So that way, if you are looking at your initial plan versus the code, that's something a team has achieved. But the coding is done, that's there in your box, but that's not going to do anything. So we have to build or compile, right? In a simple word, you compile your code, you build your code, your application, right? It's a continuous build process. Then you want to test this. It could be a unit testing, it could be a sanity regression testing. All this testing comes here, and then it goes to deployment, right? So this is a step-by-step process, right? If you don't agree, or if you think I missed any stage, feel free to let me know. Okay, then you can see this goes in a operation, right? So we need to take this in a operation to apply after the deployment operation, one who will watch, who will also monitor. Okay, and then the whole process, at every stage there is a feedback going back. Okay, from here something goes here, from testing something goes here, from deployment something goes there, operations something goes, monitoring something goes. So every time, okay, you will see some feedback is given back to the dev team, right? Maybe after all, if you have created a software, let's say, I would say you have coded a Flipkart, let's say. Okay, I hope everybody knows Flipkart, right? It's an e-commerce portal. And your team has created, coded everything, and there's a lot of code, right? So now code is there, but code won't work, right? And code cannot be in one individual's system. That's where we have a version control system, right? Git will come in picture. Okay, Git will come in picture. So maybe I would like to highlight some of the tools. Let's say coding, there is a Git or SVN, doesn't matter. It is the version control system which keeps a record of all the changes we are making in the central repository, so that business wants to secure this. It will be with business and it will be managed well. It will track the history, and maybe it will manage the collaborations. I think there needs to be a separate discussion on Git, okay, alone. Then Maven comes here, MVN, Gradle, etc. Right? There are some build tools. If I'm taking this as a Java project, okay, or if it is any other project, we have tools to build, to compile your application, right? If it is C++, it is a compiler, GNU compiler, or build or make file or make CMake utility, right? If it is a Java, it is a MVN, etc. Right? And then in the testing, if you check here, so maybe a lot of people use these days TestNG, okay, or Selenium, okay. So now don't worry, one do not have to learn everything, right? It's not about the scope of DevOps. I'm just trying to make you visualize that process, right? What you need to learn, I will come to that. Okay. So in the deployment, there is a chef, a puppet, right? Maybe if you heard about these tools, and maybe Ansible, right? We need some kind of automation to do this kind of activities. So operations also, I think deployment will be Docker Kubernetes also. Okay, Docker Kubernetes, right? In the operations, Ansible as well. Then monitoring, maybe some of the tools like Nagios or Prometheus. I think Prometheus is becoming popular. So, these are some of the tools, right? At every stage we are talking here, right? So, maybe, that's something I will try and relate little more with this diagram. So your R&D team has completed their coding, let's say, right? And now they kept it secure. They kept it in the Git repository, let's say all Java files, or maybe all CSS, or all Python files, or all HTML files. Okay, so they put all together, right? And then there has to be something called, DevOps activity, or I would say DevOps cloning, right? DevOps wants to clone this entire code. Okay, so what DevOps do is they clone, because that's where DevOps activity started. Clone, build, and deploy, right? They clone, they build, they deploy. There are very, very, sophisticated ways or automations in place. So maybe it will give more clarity when we explore some of the tools later on. But what we do after this activity, okay, we want to build, right? It's sometimes we call it a build server. Okay, it's just a virtual machine, guys, which will do this for you. Okay, or maybe you can just clone all your source code here and use that build server here somewhere in between, and make that process of building MVN or compiling your software. Then right after that, you will get a code which is machine understandable code, right? Let's say class file, etc. Okay, so that's a compilation. That's the software which hardware can understand, right? So, and right after that, there are few stages, and then there will be a production machine, right? So in the production, you will see, right, this var file or jar file is implemented, so that the end user, like customers like you and me, can place their orders here. Okay, and what is there in between these binary files and then the deployment is the continuous deployment process, CI/CD, continuous integration and continuous deployment. Okay, very soon I'll give little more clarity about the phases of DevOps lifecycle. Okay, then I will discuss little more. But yeah, here there is a quality assurance, here there is a sanity, and it goes to production, right? Maybe that is a typical process in the continuous deployment. Okay, or maybe UAT, you want to do, UAT, okay, sanity or quality assurance, right? All validations, checks happens, tests happens, and it goes into the production. So that's the process, guys. That's what, somebody wants to achieve if they want to develop and give this to the end user, right? So now the fun part or the good part of this entire process is, see, developers have done their work and they put their code, that's all. Now they don't want to take care of end to end, right, entire things. Okay, then somebody has to do this management. So operations have their own stuff to do. So the DevOps team will make this kind of a process, automated process, right? So this entire process needs to be automated. Okay, so that, and it has to be a continuous, right? The reason is this automated means automatically, if the person here makes some code change will be committed here, right? Now the terms, it will be more meaningful when we discuss about each tool in detail, right? And it's required, guys. It's not a big thing, right? If you start learning, you will really find it interesting. Okay, so maybe this guy has committed the code needs to be cloned, built, deployed, and that entire process has to be taken care by, some system automatically, right? So Jenkins comes in picture here, who is a servant or who is someone who help you to achieve this step-by-step approach, who is having a connections with all of these systems. This has connection with Maven, this has connection with the pre-prod system, this has connection with Git, this has connection with Docker, Kubernetes, production server, everything. So this is termed as like kind of plugins, right? Maybe later when we learn more about Jenkins, you can relate more, right? So Jenkins is one who does take care of all these activities for you. Okay, so DevOps engineer to automate, okay, to automate all these things through Jenkins, to automate your production deployments through Ansible, to ensure, okay, in the deployment, if you face any issues, if you have any challenges, it's not a software related challenges, that's where you need to learn about Docker, Kubernetes, right? Any deployment tools, build tools like Maven, etc., right? So that's where this tools is something what DevOps professional needs to know. Okay, and generally in the DevOps process, these tools are playing crucial role for your continuous deployment and continuous integration process, because this is a continuous process, guys. Now, one more very important point I want to make here is, why it has to be a continuous and why it has to be automated. Okay, let's say there is a big billion day or some kind of offer they came up with. So the dev team will create that feature and put it in the Git. Okay, let's say 8 a.m. in the morning. Okay, now if we do all this process manually, so it might take 2 days to really deploy, right? To build, to clone, to test, to validate everything, right? And then after 2 days, if I tell to this person that, hey, in this big billion days, we don't want XYZ, instead I want ABC, right? So now what do you think? These 2 days wasted, right? This 2 days wasted. The feedback you got is after 2 days, right? Feedback you got is after 2 days. Now, what if this time is reduced? If this person gets this feedback in next 1 hour, right? So if the person gets this feedback in next half an hour, right? And that is something can be achieved through this automation by DevOps team, right? So automation in the sense, there are facilities where we can optimize this process. Okay, we can optimize this, we can build, we can deploy without really doing anything manually, right? So giving this fast feedback is what helps you adapt the faster updates the dev team makes in the product. Okay, so teams can deliver quickly, deployments can become smooth, right? And this is a continuous process of improving the efficiency, and that's what the software development life cycle, okay, software development life cycle, the process, okay, maybe that helps you to have that continuous integration and continuous deployment. Okay, that's why we say DevOps is a process, is an approach, I would say, right? Approach to reduce the gap between developers and operations. So now, I hope I'm making sense here. This is an overview. This is the this is what something I wanted to tell you with respect to the entire DevOps process. So and I'm sure like I need little more time to give you clarity about each tool, right? Considering the time constraint, I will quickly take you through overview of these tools and what is that something you have to do for jumping into the DevOps. Okay. Now, first thing is, think DevOps as if it's a need of the industry, irrespective of any role, right? Don't think like, you want to go in DevOps or you don't want to. You can be a software developer, but you need to know DevOps. In Agile, we don't want to really keep a separate team. Okay, so developers also test, developers also deploy. So DevOps needs to be there with the developer. as well as dedicated DevOps teams are required to manage the productions and probably the end-to-end flow right from the software developers to the deployments. That is the entire software development life cycle. Okay, so and hence DevOps is must have skills in your resume, I would say, right? So whichever role you are currently, whatever stage you are in your career, so this DevOps is something which is important for the modern software development life cycle. Okay, so and that's why, like I say, many companies, major giants or the small companies, right, who are startups, they opt for DevOps approach because that that supports or that helps reduce the delivery time and the gap between the developers and operations. Okay, that is what the the DevOps cycle will help you. And there are some tools, as I mentioned, like Git, Maven. It comes in the development side. Jenkins also, because here we use some programming like Java or Groovy or Python, okay, to automate some of the things maybe developers will do for you. But you should know how Jenkins work. You don't have to develop that automation probably, but you should know what is Jenkins, how the automated pipeline gets created, right? And what are the tools we need to know, how the plugins are created, how the plugins are installed, how to set up a Jenkins server. Okay, the life is simple these days, right? You can go to cloud, you can create account on AWS, right? And create a EC2 instance, and many times for the learners we get free server, guys. We don't really have to even pay, right? So you can try, you can do all these R&D or join some course, some kind of a tutor, or check with the counselors if they can have some guidance for you, so that you get a direction on how to take these activities, right? So installing Jenkins, playing with Jenkins, not a big deal, right? But you have to do it. Unless you do it, you don't get the confidence. Theory is not going to help, right? Linux, hands-on on Linux is another important thing. Linux operating system, right? In the industry, this is really important, right? Person has to know. If you don't know, not a big deal. It's a free for you, right? You go to AWS instance, you create one account and you start directly using, right? Let's say I have one system, right? Maybe I'll open something. So I have, this is a cloud-based instance. I don't log in on my console, or you can do so, okay, through console.aws.amazon.com. Okay, if you log in, right, you can create your own EC2 instance. EC2 instance is your, VM, virtual machine, which you get, and you can start working there, right? For example, I have just initiated that and I connect to this particular server. Okay, so you can do so. I'm using through Python, but yeah, see here, I have two EC2 instances. Okay, and one of them I have just started, right, with this ID. Do you see this ID? So I use this ID to start, and this VM is now running. See here, I used this ID to start, and my VM is now running. So I can probably connect. Okay, maybe if it has some issue, I will check. Yeah, once it comes up, it takes little time. Yeah, now it is up. See, this is a Linux machine and it is almost for free, guys. You don't have to really pay. You just have to explore what is cloud computing, what is AWS, and probably start with one EC2 instance and play with the commands. Okay, see what you can do. Can you check how to install Maven? Can you check how to install Git and Git clone some project, and you can probably play with. So these are the things, I wish I could show you more, but basis on our time constraint, I'm just trying to give you a glimpse. So how do you, learn, right? These skills, these are mandatory, these are important, right? In the industry, one needs to know this. Okay, these are basics, I would say, right? More time you spend, it will create more value into your career. So coming back, any question? I'll pause for 10 seconds again. If you have any question, anybody wants to discuss something, feel free to interrupt. So Milind, DevOps required skills, right? I think that's a question, and I think in last few minutes that was a very old question. In last few minutes, I tried to give you the idea about the skills required for DevOps. I hope Milind, you got the answer. Shubham, what is the difference between CI and CD? Perfect. That's a nice question, Shubham. Perfect. So I will probably discuss a little more about this. So I have tried to give you a little idea about the continuous integration process. Continuous integration process, right? So yeah, I think Khalil has answered. It's a continuous integration and continuous delivery and continuous deployment. Excellent. Yeah, that's the full form, but maybe I would like to add a little bit more on top of it. Okay. No, that's nice, Khalil. That's a good answer. So to answer you, Shubham, I think I can probably tell you one thing. So continuous integration means I want to integrate all these different components in the software development life cycle to take care of your entire process automatically, right? And that's a continuous integration. Continuous, feedback will be provided. It's a continuous process, right? So that's what I mentioned here, the infinity symbol. So it's a continuous, you code, developers reading, right? They probably fix the issue, they probably develop new feature, but that happens every day, correct? So developers do code, the build has to happen automatically the moment code is committed in the repository, let's say Git repository. And then your test process will be automated testing again, and there is a release. That's what we release and deploy, right? So there are release versions, numbers, everything is decided in the planning phase itself, and then once it is released, it will be deployed, and then it will be monitored. And then that's not over, guys, right? Once you are at the monitoring stage, right? So if you check here, so just a minute, yeah, if you check here, so monitoring again goes back to the planning and coding stage. That means from here, the feedback goes. The feedback is a continuous process, right? And DevOps is a continuous process of improvement. So that's why it is a continuous integration, right? There are 7 phases in the DevOps life cycle. It's not only continuous integration, continuous deployment, but continuous development happens. Continuous integration needs to be there. Continuous testing will be there, right? And then monitoring, feedback, deployment, and operations. I have some bit of a theory around discussion about continuous integration. Okay, and then I will quickly tell you about continuous delivery or continuous deployment. Okay, continuous delivery and continuous deployment is a slight difference, but both are termed as CD. Okay, and CI is a continuous integration. Okay, it's a process. It's a process of your development. Once you commit the code, build it, test it, and then deploy, right? That's a continuous integration process. So in a software development practice, the code commit happens very frequently, because I have worked in many projects. I would say every 1 hour something will be committed by somebody in the team, right? Assume the developers are there, let's say 20 developers are working on daily basis. So even 2 developers commit 2 times in a day, you get couple of 4 times code committed, right? It has to be detected automatically, right? That's what the commit hooks are created to ensure this is automatically detected, right? Jenkins does that. Jenkins has this kind of integration. That's why we term it as a continuous integration process, right? It will build the code, it will invoke that compilation process, and it will not only build, but it will do unit test, it will do integration test, it will do your code review integration. Even if you find issue, it will raise the ticket in Jira automatically. So that kind of automation, that kind of integration is a continuous process, and hence it's a continuous integration, right? And if you look at this continuous delivery on the right hand side, okay, here you will see it's a process that operations and developers, they they deliver their feedbacks through bug fixes or through new features or any kind of changes you make in the production, how soon you can do, how fast you can update, and how your delivery will be quicker, right? And that deployment goes in a smoother way. So continuous delivery offers the benefit of code delivery through the pipelines. Now, why we call it pipeline is, if you look at this diagram, okay, it's like a pipeline, guys. One first one and then the second one. Okay, makes sense. So build, I cannot build unless there is a commit. I cannot test unless there is a build. Okay, and that's what the pipeline is, right? Pipeline will have okay, stages, right? The first in first out kind of a mechanism, right? And that's why it is a pipeline, and that's why it is a continuous integration and continuous delivery. I hope I answered your query, Shubham. All right. Now, after every changes in the day, we'll test it and ask feedback to the client. Okay, excellent. That's nice. Okay, cool. Thank you. Any other question? I'll quickly pause here, and maybe another couple of minutes. I want to wind up, and then I will open up for the questions or your queries. If you have any, you can unmute, speak up.
Hello. Hello,
Yeah.
Ganesh. I'm Tushar. Ganesh, as a fresher, means what kind of tools and which roadmaps we need to follow? Please tell us. Means,
Mhm.
as a fresher, which tool we need to learn and what roadmap we need to follow?
All right. Okay. I got it, Tushar. I will answer that. Yeah, Sushant, do you have something or similar question? Okay. Anyone has a similar question? As a fresher, right? What do you think? What is the best thing, or where to start, what to learn, which tool to start with, which tool to learn? Okay, very good. So first thing is, even if you are a fresher, I hope you have a programming background, right? A little bit of, if not expert, right? You might have gone through Java in your academics, or you might have gone through C, C++, Python, etc. Then you have a bit of a fair idea on programming languages, right? If you think you cannot do too much into programming languages, right? Or if you are thinking that development, job is not really something really exciting, so you might be thinking what to do to get in the industry, right? So, or even if you are good in programming, what is that will help you to get in the industry, right? So, guys, first I will tell you, take at least one course, okay, somewhere, and join, or start with some flow, okay? And the field is really vast, because as I mentioned earlier, so in the entire evolution in the industry today, a person need to know so many things, right? Person need to know cloud, what is cloud, the basics of it. Person needs to know Git, person needs to know Maven, let's say. Person needs to know basics of Java. But basics, even before that, somebody needs to know Linux, right? So I would say, as a fresher, okay, take one at a time and really go deeper into that. Let's say Linux, first you understand, gets the hands on, okay? Understand and gets the hands on. Nobody will really ask you questions on Linux, probably. Nobody will check your Linux skills. But yeah, there are few people check your Linux skills. If you don't know Linux, it will be difficult. That's the first tip, okay? Second, you go with the, let's say, DevOps processes. You start learning. First, you learn Jenkins, understand what it is, how Jenkins can help you automate some of the things. You create small projects, you create your account in the GitHub. Okay, I hope you already have account in the GitHub. If not, create. There are so many open source projects. You can write some demo code. Let's say I have so many here, right? So demo project you can create, that's a Python code, maybe you can create some Java code, and you try and integrate that with some of the Java project, I would say. Okay, so that will give you a confidence of end-to-end delivery deployment process. Okay, it's a simple hello world program, guys, not a big deal, right? But how do you think this can be pulled by Git? So again, Git comes here, you need to learn Git. Okay, these are the tools, not really complicated, but this will help you get more confidence. Even if you are a fresher, be open for any role, but learn these things. These are required for any position. Even if you go as a software developer, you need to know these things. So I hope, Tushar, this makes sense to you. Did you get your answer?
Yes, Ganesh, thank you. Yeah.
Okay. Okay, excellent. So yeah, again, that's what I said. Like the field is vast. Join something and start with doing step by step, right? Generally, in the DevOps course, all the tools are covered. Okay, one time if somebody covers, you can go a little deeper by your own. Okay, you'll get a direction by taking some tutor or some guide that will help you, to start with. Otherwise, you will be lost. There are, you know so many resources, and there are so many things to discuss and learn. So learning these tools will help you in any role, guys. Okay, that's most important point I want to say. Okay, learn all these tools. Okay, and then probably you will get some more idea. Okay, so yeah, any other question? I think Dimple, as a fresher, first of all, you need to know about Linux. I would say yes, Dimple, but Linux is not the only skill or mandatory skill, I would say. Okay, but Linux is something majority of the companies need. So I think you should learn, right? It's not a really complicated, but if you are new, you will find it really complicated OS. But once you learn, a matter of 1 week or 2 weeks, you will find it really interesting, and you will be comfortable. Right? Learn Linux. Linux is the knowledge which will never die. Okay. In my very first job, I used Linux. I wrote some small scripts for, some task in my work. Okay. And even today I do write some kind of a script or some kind of a, stuff in Linux. So Linux will be there, right? Many things came, many things gone. Okay. I learned Perl, I learned what not, right? Everything, but nothing is there, right? Today, I'm more into Python, maybe I'm more into Groovy, I'm more into DevOps automation, right? I'm more into cloud, uh, but Linux is still there everywhere. Okay, so I'm not working anymore on C++ now. All right, I think Dimple got the answer. Any other question? Anybody wants to
Yes,
unmute and
Ganesh.
speak?
Yeah, Ganesh, this is Mahesh here.
Yeah.
For DevOps, Python is mandatory, yeah? Or else, can you please tell her is Python is mandatory? Because or scripting, I know scripting is mandatory, but
Uh,
what Python?
Yeah, see, Mahesh, I think, Python is required. Okay, I won't say mandatory, but one of the programming language is required. Suppose if you say you are a DevOps engineer, at least you have to say, let's say Groovy, or you have to say shell scripting, or you have to say Python. So at least you can say, yeah, I have automated these things. I have worked on fixing these issues. So Python is required. It's important these days. Python or any programming or any tool which will help you code somewhere in Jenkins or wherever you need. Okay, but Python, because a lot of people use Python for quite many things. So I would say yes, learn Python. Again, I'm telling you, I'm giving you confidence that this is not a tough thing, guys. It's not like Java or C++ you learn spend a lot of times, but Python is simpler relatively, comparatively the other languages. Okay.
Yeah. But the reason I choose the DevOps is there will be a no coding, but now you telling that Python is required, so I just confused whether which I have to choose now.
No, don't worry. Like, you don't have to do too much of coding. Okay, I will tell you the difference. Okay, first, let me tell you now. Let me clarify that doubt. Okay. I worked as a developer. I worked as a DevOps engineer. I worked as a SRE also. Okay. Now, SRE, site reliability engineering, they don't code. DevOps, they really don't code. Okay. But knowing to the learning, to the reading purpose is required. And see, when I say you learn Python, you don't have to code. You don't have to be a software developer to do all of coding. So coding will be done by developers. Okay, at least you should know by reading the code. That much is needed. You don't have to be expert there. but learn something. You write in the cell. See, even testing now, maybe somebody asked any testing courses, and I believe a lot of people choose testing courses. Okay. So if you are thinking testing doesn't need programming, no, that's wrong. Testing also need programming, but does tester need to do code like a developer? Answer is no. So tester has to learn something for doing some quick stuff, doing some simple stuff, doing some kind of automations, some kind of a scripting. So Python is, something you learn for scripting. You don't have to go with the multi-threaded concurrent programming to develop complex logic. Okay, that is a developer's work. But you can do some simple stuff like you got an Excel sheet, you parse a couple of rows, and maybe you pull out some data from that. That kind of stuff is in day-to-day work, guys. Okay, you have to be a little bit flexible for learning. Is that make sense, Mahesh? Or
Yeah. But all the three we require scripting language, Groovy, Shell, Python, like that. Any one is
not really. Don't worry. Don't learn anything on GUI. Okay. Then you don't have to be expert in Python. Linux, I'm saying Linux working knowledge. You don't have to even script a lot. Working knowledge will help you to read scripts, understand what the script is doing. That much is enough, Mahesh.
Yeah, okay. Because in DevOps only we have nearly 7 to 8 tools, and apart from that, scripting and apart from Linux, it's getting very scared to get into the DevOps.
That's what I said in my very first discussion when I showed you this. So it is not to scare you, but all these tools you need to know. That doesn't mean you have to be expert in all these things, right? So you don't have to be expert in Selenium. There is a test team who does all this automation through Selenium. Okay. But yeah, that's what, like some of the basics of Git, some of the basics of Docker Kubernetes. Now, Docker Kubernetes is also very fast, guys, right? It's a vast thing. You don't have to be expert here. Okay. The Jenkins, trust me, if you go through some course on YouTube, you will find it easy. You don't have to develop the jobs. Jobs are there. You need to know how to trigger a job. You need to know how to check the logs. If you find some application specific issue, you will route it to development team. You don't do coding. So that kind of basic knowledge is needed, Mahesh. And it is not really tough. Okay. And that's why people choose DevOps, and most of the things are simpler these days.
Yeah, okay. So finally, I understand that start the process, we require some scripting languages. That's it, right?
Yes, right. No need of coding for DevOps engineer. You should have some scripting hands-on. Yeah, that's what Khalil has just messaged. I think that's the good point, and that's what I have been saying. We don't have to be a coder there, right? But some kind of a reading, some kind of a scripting will help you to work efficiently, guys. It is for you, not for interview. Nobody will ask you to write code for in the interview. They will ask what Git does, how do you manage the conflicts, etc. Right? They might ask you, Jenkins, how do you create pipeline, how do you trigger on the cloud, right? Maybe those are some of the things. Okay. I think I'm running out of time. I still want to take, if there are any questions, I'll pause for 10 seconds. Let me know. All right. So I hope I was able to answer your queries. I hope this session was a value add to your 1 hour of time. So I thank everyone once again, and I wish all of you a very best luck for your learnings. Like, keep learning, guys. Keep in touch with the technology. Right, things will definitely fall in place for your career. Okay, thank you again, and feel free to connect to our counselor for any guidance or suggestion. Right, and thanks. Have a good day, guys. Thank you.